Welcome to our webcast, Connecting Infrastructure, Simplifying Infrastructure for IoT and Connected Enterprise, sponsored by Panduit. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering. To get the best results from the Control Engineering webcast platform, please note the following as you participate in today's event. If you are having technical problems with audio or the slide presentation, click on the question mark at the top right corner of the screen to bring up a list of system checks to make before escalating to an online technician. If you're experiencing issues with your slides or audio, please refresh your browser or click the Refresh Media button directly under the presenter's headshot. You can control the volume settings of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you need a technician, type a message into the Ask a Question box and someone will get back to you as quickly as possible. Individual technical questions will be answered in the Answered Questions area on the left side of your screen. You can use the Ask a Question box on the left side of your screen to type the questions for the speaker during the presentation for the Q&A session at the end. You may ask questions at any time during the presentation, and we'll get to as many as time allows. Questions that are for today's presenter will be answered verbally during the Q&A session at the end of the webcast. To download the presentation slides, or if you'd like to download a certificate of completion from today's event, use the event resources on the left side of your screen. This webcast is being recorded, including the Q&A session. We'll post the archive on the Control Engineering website in a few days, and we will send you an email message with a link connecting directly to it after it's ready. Today's webcast sponsor is Panduit. Thank you for supporting this program. Now I'm happy to introduce today's distinguished speaker. Dan McGrath is the Solutions Manager for the Industrial Automation Infrastructure Group at Panduit Corporation. Dan is Panduit's lead for Industrial IP Advantage, which is a coalition launched by Panduit, Cisco, and Rockwell Automation, promoting standard unmodified Ethernet and Internet protocol for industrial applications. Dan has over 25 years' experience in automation and industrial networking for global manufacturing operations. He holds a Bachelor of Science degree in electrical engineering and has attained a professional engineer and an ASQ certified quality engineer certifications. I'm Mark T. Hosky, webcast moderator and content manager for Control Engineering since 1994. Before we continue, please take a moment to remind yourself about dealing with technical issues during the presentation. And now we'll hear from Dan.
Thank you, Mark, and thank you all for joining. I think most would agree we are entering a great time for value creation that will transform industrial businesses and even careers using the power of Internet protocol networks, connecting many more things wired and wirelessly. The connected enterprise offers real value from unlocking the value of data from processes, machines, and by timely decision-making to avoid waste, by integrating control and information. But let's be honest, when you think of your plants and factories, is your network infrastructure really ready to securely share, transport, and process all this data? Wireless, video, mobility, virtualization, maybe even cloud services? One recent customer relayed how the plant managers wanted to implement mobile tablet access to real-time production data, but they had to tell them that their plant network was only 10 megabit with no firewalls. Definitely not ready to make that jump. Too often plants suffer from this older infrastructure that may not have enough bandwidth, may not have adequate segmentation, and has serious security holes. So today we're going to take a deeper look at how to consider and assess whether your plant is ready, and then talk about tools and approaches to simplify how you plan, design, and deploy, and look at case studies and resources to assist you in your journey. So next, really, when you start looking at the connected enterprise, what does that really mean? It starts by connecting devices, process skids, machines, and many companies are well along the path there. But when you start trying to connect to the whole plant and integrate production lines and then finally to the enterprise and beyond to the cloud, you really have to look at, have you put in place a very strong, secure architecture focus, like converged plant-wide Ethernet reference architecture? Have you taken the time to develop a structured physical infrastructure that is future-ready, that can handle all the new nodes, whether it's video, wireless, and so on, that will generate more bandwidth and provide all this capabilities that customers and plants are demanding to have mobile access, remote access by OEMs and machine builders. A recent survey showed that only about 14% of plants have integrated the plant and enterprise. So the real question here is, what is your plan to get your share of this $3.88 billion at stake from the Internet of Things? It really starts by tackling it from the machine level, then to your plant, and then to the enterprise. And when you start looking at it, a lot of these plants today, areas of your plant may still have traditional three-tier network model in that you have a separate control network, a separate device network, a separate enterprise network. You may start progressing to this converged plant-wide Ethernet IP model that leverages the power of managed switching and routing and the best practices from the IT world for security and performance, so that you create a plant that is much more capable. So you may be down that journey, but you really have to start looking, is it capable of the next steps? So when you start opening up your plant floor to a machine builder that has remote access capability that can help you reduce costs, do you have security in place? When you want to do mobility across your plant floor, do you have an infrastructure with enough bandwidth to support wireless? And video is being used as a new eye, a new sensor to aid in troubleshooting or for quality. And that, again, do you have segmentation in place? Do you have a managed switching architecture that has enough bandwidth and capabilities? Now, as these pictures come up on your screen, this is what I'm talking about when I'm saying, are you being honest? Take a walk around your plant. I hope you don't see too many areas like this. But when I talk to customers at events and so on, this is all too common. It becomes a real pitfall to have this obsolete infrastructure that maybe had one too many change or lack of planning. And ultimately, it's really risking the value that you can create, the performance challenges, even security. If you don't know what's connected where, how can you be sure that assets are protected? Some stats here: a significant portion of network downtime, approximately 80%, is attributed to physical layer connections. So when you start looking at an industrial plant and you're working with IT, have you really considered the environment and specified media or the suitable enclosures that are secure and industrially rated? This can all affect uptime. The security concerns I mentioned, here's a stat that 40% list security concerns as a real barrier to Internet of Things and Internet connectivity to machines. So the aspect of having a structured network in place that is documented and secure is really a foundational element of achieving this value. And when you look at it from the standpoint of investment, sometimes physical infrastructure gets left to the last minute, maybe to an installer that's not even given specs or drawings. And when you look at what did it cost your operation if you find a problem after you've deployed, it's exponentially higher. So if you can catch a problem during the plan and design stage, it's much more cost effective than after you go into operate. One customer, a biotech making anti-cancer drugs, they really recognize this fact and put a lot of effort into resiliency, redundant rings, and best practices, because 1 minute of downtime, they could lose a $3 million batch. So this idea of looking at the infrastructure as an area that requires planning and design is becoming more and more critical as networks become more critical. And too often, the reality is that these are resolved late. We've had customers that have had to rip out and replace much of their plant network during a startup because they chose the wrong media. They went with like a shielded media without adequate grounding and bonding in place, and they came to Panduit, help us develop a plan and architecture to avoid these kind of problems. So when you look at best-in-class manufacturers, this analyst study showed that best-in-class manufacturers that are achieving the high levels of uptime, the high levels of 90% OEE, and lower total cost of ownership are spending more time with looking at the reliability of their network, using redundancy, looking at how they manage the physical layer and the cabling installations throughout the plant. So the point of this slide is that the best-in-class manufacturers that have invested in data and networking realize the foundation of the physical layer requires planning and management, kind of a life cycle thought process. And it's really about that discipline. Do you have company specs for the physical layer for your industrial plant? Often the office building part of your network, IT has worked those out. But what does it look like for your industrial plant? So today we're going to really look at some tools that will simplify how you plan, design, and deploy. It starts with reference architectures, and then we'll go into how you define organizational goals and path for the physical layer by using some maturity and execution models, and ultimately arm you with what you need to know to do better budgeting and resource planning. So reference architectures are the foundation for success. Panduit has been partnering with Rockwell Automation and Cisco for a number of years, working on validated architectures for the IT side, as well as for the automation manufacturing plant, the operations technology or OT side. So the idea here is that when you deploy switches, routers, servers, and so on, whether it's in a data center or a smart building, there are some best practices for deployment that can ensure success. And when we look at the automation space on the industrial plants, we've worked on reference architectures that have that outline the best practices that have the basis of actually being tested in Panduit labs and with our partners. So these documents are available on the Cisco website, Rockwell Automation, and Panduit websites across all the spectrum, from the data center to enterprise to plant floor. Many people know Panduit from control panels, wiring duct, and so on, but may not realize that half of our business is involved with data center and enterprise network connectivity, fiber optics, copper cabling, racks, cabinets, and so on. And this is because all this networking technology is coming to the plant floor. This role of describing best practices is an area that we're really partnering with industry leaders to help you deploy. One of the key areas of partnering is an organization called Industrial IP Advantage. We have a website, and we'll provide the URL later in the presentation, but it's focused on articles and application guides, how-to information, blogs about industrial networking. So reference architectures give you that best practice structure of how to arrange a network. The idea of execution and maturity models are to help you plan your steps ahead. Where do you want to go as an organization? Where are you today? And what are the steps and stages to get there? So the connected enterprise is Rockwell Automation's vision for how to achieve full value of connecting the enterprise with the plant floor and using the data for collaboration and analytics. The first two stages are an area that Panduit is especially engaged with, the assessment and the securing and upgrading of the network and controls. This is an area where the physical infrastructure is really a key area. To that end, Panduit has developed a network fabric maturity model for the industrial plant physical infrastructure. This is a model we put together that describes some of the stages that we've seen our key customers and partners implement. The first stage is where many plants have started at, where there's a sprawl of networks. You may have a number of older field bus networks in place, possibly islands of data that's not connected, more reactive support. Maybe you think you have security, that's security by obscurity, but it's really a false sense. It's really restrictive in terms of what value it can create for your organization. So many have progressed to what we show as step 2 here, functional. That is, you've begun to embrace IP, Internet Protocol, Ethernet IP, pervasively across your plant. And that is driving some real benefits. You've stepped up and you've specified the connectivity with sealed, harsh-rated, industrial-rated cabling and connectors. But you still have a little bit of issues connecting to the enterprise, minimal convergence. You're not really fully there yet as far as an architecture. Your machines, your process skids, your production lines may be functioning quite well, but you have severe limitations in how you can acquire data or how machine builders or remote experts can help you. So we're really pointing to stages 3 and 4. This is where you're beginning to embrace architecture, converged plant-wide Ethernet, CPWE. You've put in place building blocks for the physical layer that embrace physical layer standards and best practices. You've begun to use virtualization and paid more attention to the infrastructure in your annual planning process so that you are prepared for the growth of networks and for the use of wireless. The plans are in place to audit the security as part of the defense in depth. So we see many companies moving from 2 to 3 by embracing these reference architectures we spoke of. This is really the start of bring together OT and IT, and with the end in mind of really moving to become much more innovative, driving the innovation in your company by using wired and wireless, by using virtualization and remote services, cloud. You now are using much more predictive and hyper awareness of the health of the network itself. You have a holistic network plan between enterprise and plant so that you're able to support and scale your network and have confidence in the security. So those last two stages, there's much more focus on mission, vision, and business outcome. So this network maturity model we put together, and we've been using it with some of our key customers and integrator partners, and we're getting feedback that this really helps kind of chart that path, understand where you are today and where you desire to go in the future, and some of the key areas. So let's just take a little deeper dive into this. So first off, is your plant or areas in your plant still at that level 1 restrictive? What are those cost-saving practices? Maybe it's a benign neglect kind of a thing. Are you still using proprietary field buses or have tiered networks and islands of data? This really creates barriers to data use. The use of low-cost, commercial-grade, unmanaged switches can create troubleshooting and security issues when you start digging into support. One large customer had real concerns about their engineers dialing in, and they just had a sprawl of unmanaged switches. How do they know who's making changes at what time? Is it really secure and safe? And finally, the use of non-tested office-grade type infrastructure can risk performance and uptime. People can spend a lot of time and effort specifying, starting up the best software, the best control hardware, and then they'll use an off-the-shelf patch cord that the cheapest they could find, or that sort of thing, that an installer, you don't even know what they're putting in, or they're making themselves. And that could be the weak link that reduces your uptime. So the opportunity here is to embrace best practices and standards of simplified lifecycle. So when you start doing that and embracing those best practices, you'll find that you're able to access much more data from your drives and control system because you've standardized on IP and Ethernet IP, and you've progressed beyond using office-grade connectivity or homemade, and you're starting to specify for the environment industrially rated connectors, media, and switches that have temperature ratings, that have vibration ratings, sealing. So now you know that you can count on this infrastructure, and it ultimately you're much more functional, but there are still challenges in many cases. You're focused on your machine and your process, but what about your plant-wide network? Are you still reliant on unmanaged switches? Have you installed a few managed switches, but really have not taken the time to configure properly? These infrastructure gaps can really impede how you can provide remote access to your engineers. They can become a real trouble spot when you start connecting to the enterprise. So this is really where the role of reference architecture can help you progress beyond this level 2. So level 3, when you have an effective plant network, you really have an architecture in place. And this is where Panduit has been partnering to supply tools to help simplify. I show how the various zones of converged plant-wide Ethernet, from the cell area zone where the equipment's deployed in control panels, Panduit has solutions to simplify how you deploy the fiber optic and copper cabling down to the machine level. Then we have integrated zone enclosures that help deploy access level switches in a zone for a cell area deployment. Now industrial distribution frames that house 19-inch rack switches for the distribution layer, and industrial data centers where you house the factory talk, vantage point, or other plant-wide software that are part of the industrial zone. So these reference architectures help you deploy and improve in the maturity model, progress so that you get more value from your data. And what we're really talking about here are tools to help you simplify. And when you look at that level 3, it's about use of best practices for structured cabling from the enterprise to the plant. This little roadmap from Panduit shows that on the enterprise side, there is a lot of thought put in to how you structure the network, from telecommunication room to the office areas, with a repeatable structure that is testable. And there are standards that we'll talk about and building blocks that can help you do the same sort of repeatable, scalable structure that you can count on for the factory floor. Level 4 of the maturity model is really getting into innovation. Cloud and fog services, edge computing, using wireless and mobility pervasively, wireless mesh networks for those new type of architectures where you're adding in low-cost sensors in hard-to-reach places and using gateways and so on to bring the data into your architecture, and even innovations in network manageability. Panduit has acquired a company, SnapSense, that is strong on the data center side with wireless temperature, humidity, power type sensors, and to build a smart infrastructure. And we're bringing some of that technology to the plant floor so to improve network manageability and innovation. We have an article on our industrial IP site about it. So in general, this network maturity model is a way to help you assess where you are today and plan out where you want to go in the future. And we're releasing a white paper on this. But one of the key takeaways out of the whole architecture and maturity model is to really think about how you prioritize the physical infrastructure budget. Often the software, the networking, the operations take the majority of the investment dollar, but your cabling infrastructure, your plant backbone, your cabinets, your physical layer are a small part of your budget, but that can have huge effects. Here we show, again, that stat about the downtime, but it's only a small part of the budget. So the message here is that by spending more time in considering your path ahead, you can make wiser investment choices. So now that we've talked through some of the tools and architectures, it's really about how do you deploy and simplify that so you don't end up with a spaghetti mess of cabling or an undocumented network that's a challenge to support. This slide shows how a lot of the networks get installed from the control panel up. You know, you may have electricians, plant electricians, technicians configuring the networks at the machine level, at the control panel level. But for the connected enterprise and for Internet of Things type applications, we need to also reach down from IT to the factory floor. And this is where the industrial data center and zone architecture systems can help simplify. Panduit is engaged in other ways to simplify creating a robust network deployment. Some of it has to do with how you ensure repeatable, reliable connections, install an effective grounding and bonding infrastructure, education, white papers, and training we have about assessing the environment, managing the cabling and EMI noise by separating noise sources like VFD drives, cabling from Ethernet cabling, and then leveraging standards and best practices for segmentation and securing the network across the plant. So these are all key areas that Panduit focuses on, and we have solutions and services that can help you. One of the key reference documents that we train on and use as part of our solutions is the TIA organization's standard for industrial premises, published in 2012. It takes a lot of that best practice structured cabling know-how that's been well proven for Ethernet networks and considers the environment and topologies for the plant floor and industrial premise. And this covers off on areas like how many connectors in a channel, the topologies, what are some of the key considerations for the environment, so that you can ensure that your plant network will perform. Panduit takes that know-how of structured cabling and that IT reaching down to the plant floor and has developed a reference design and a series of articles and configuration drawings that talk about building blocks. So the idea of taking a network from the IT space out to the plant floor with the distribution level switches at the plant level to a zone enclosure with hardened industrial switches so that the fiber backbone throughout the plant can then have drops of copper down to control panels or out onto the machine. So this simplifies switch deployment by housing switches in integrated, tested, validated solutions at the plant level, zone level, with solutions to distribute that cabling throughout the panels and machine level. So we'll take a brief look at each of these building blocks. One, what we're showing here is the Essentials Plus Industrial Data Center that's sold by Rockwell Automation. Panduit does the enclosures, the cable management, and the testing to create a robust physical infrastructure. So the idea of this building block is it has the servers, switching, and storage as a single part number that you can order and use to house the virtualization, all the VMs that you need for PlantPAX or for Factory Talk. So the idea here is to speed deployment and improve the uptime of your systems by using validated architectures. So the logical architecture of the switches and servers, but also the physical layer. We've tested this thermally in our lab. We verified the grounding and bonding and power. The cable management is well identified and ready for support and installation. Next, we'll look at the intermediate distribution frame, the industrial distribution frame. The idea here is with the density of connections, the use of power over Ethernet to wireless access points and video, the greater use of fiber and copper throughout the plant, the density is going up so that a typical control panel mounted switch with 12 or 20 connections isn't enough. You may need a consolidation point for 19-inch rack equipment where you can put a stack switch into the enclosure, but yet it's industrially hardened. So NEMA, it's a UL type 412, IP66 enclosure with cooling options, air conditioning, and so on. So this can be rapidly deployed as a building block, all pre-configured with all the physical infrastructure. So you just install your switching and can allow for a much more rapid deployment that's more scalable and secure since it's a locked enclosure. When you get closer to the plant or process line or the machine itself, often today switches are located inside of control panels, but that can be an issue. Sometimes there's high voltages, there's power up-down cycle issues where during troubleshooting or plant operation cycles, and the ability to troubleshoot and share the management of this critical infrastructure layer between IT and operations people can be an issue. So Panduit has developed an integrated network zone system that includes the network switch, the power supplies, UPS, the fiber and copper patching areas, and all the patch cords as a single part number building block. So the idea of this is one large tire company, they use a similar approach. They put a zone enclosure every other building column in their plant, and then they have drops down to their control panels or the wireless access point or video. We'll go through a couple case studies for Panduit as well, where this approach of an integrated network zone enclosure greatly reduced the installation time and startup time. So if you take that building block idea and extend it to how do you deploy a plant-wide fiber backbone, Panduit has tools and architectures to help you with this. We have popular configuration drawings that give you a representative diagram like this and call out all the suitable single mode, multi-mode type fiber options that you may consider. And it's really about looking at the environmental, the reach, the distance that you need, the density of the connections. One of the innovations Panduit's come up with is a backbone cabling that is very robust. It has a hardened plastic armoring, so it's all dielectric. So that means there's no steel that needs to be bonded, but yet it's lightweight and crush resistant. So this can be quickly deployed without conduit. You can install on J-hooks, and it's available in a variety of fiber counts and media types, and greatly reduces the installation time for your plant backbone. Another innovation from Panduit is a polymer-coated fiber, or PCF fiber, that has a standard 50-micron inner core multi-mode fiber, but a larger diameter 200-micron outer coating. And what this means is an electrician can strip the cable and install it with more common tools and a lot less time and expertise. This slide shows the steps. You essentially load the connector into a crimper, strip the PCF fiber with kind of like handling an 18-gauge wire, and just strip it, insert the fiber in the connector, crimp it, cleave it with the cleave tool, and put on the back shell. So no polishing, no critical alignments, and it's a much more rugged, robust fiber to handle because of the larger diameter. Structured cabling is at the heart of bringing order to the plant network. What we're showing here is the channel model for a structured cabling system. Typically, this consists of a permanent link that would be installed between two locations, such as a zone enclosure and a control panel. And then you would install jacks in a patch field in each location and then use pre-tested patch cords. So the use of structured cabling and testing the performance can greatly improve the uptime and future readiness of your network. So if you just install a point-to-point cable and crimp on a plug and get a green light, do you really know whether you have Cat 6 gigabit performance capability? You might find out during a troubleshooting when you start having dropouts or some issues. So the point here is use best practices, use testing tools, and you can have much greater success longer term. Panduit has a full line of industrial copper media today that's designed for industrial with durable jackets with M12 and hardened RJ45 connectors, including 600 volt rated cabling for use near high voltage and control panels. So, as we get through these building blocks, it's really about how do we simplify, and this is where Panduit has developed services that help assess and look at the complex architectures and how to protect them. So we look at the grounding and bonding in your plant, how and where you deploy network switches, and make recommendations. So we're showing some of the forms that we have that we can look at and assess and help you develop network planning documents for the physical layer, how to deploy those building blocks from the industrial data center to the IDF to the zone, how to specify and where to use single mode versus multi-mode fiber cabling and copper cabling structures, such that in the end you have a well-documented, future-ready, industrially rated plant network. So at this point we'll go through a couple of case studies. One is a water treatment plant in Santa Margarita, California, and they were looking at doing a plant update. They had a lot of obsolete infrastructure. They were the plan was to develop and install wireless access points throughout the plant, and they came to Panduit. They saw our building block approach to simplification, and in the end they selected our integrated zone enclosure system. They had budgeted, they thought this might take them a year to roll out throughout their site, but the project installed in 3 months. It used the Stratix switches and PoE capabilities. We had Panduit fiber optic uplinks for that robust plant backbone, and the copper connections that fed the video cameras and so on. So this reduced the risks and the startup checks because it all shipped as this integrated zone as a unit, and by installing the fiber and then starting it up, they realized a lot of time savings. Another example from the metals industry, this plant had a large architecture that required 4 micro data centers for servers and switches, 27 of these integrated zone enclosures, over 45,000 feet of OM4 fiber, as well as our Panduit services to help develop the installation specs and project management. So this helped this customer meet their project launch date and have a scalable system that much more secure and founded on architecture best practices. So this slide speaks to Panduit's breadth. We have services that span from the data center enterprise down to the plant floor, looking at the network logical deployments and what is really required for performance and long-term success, both on the IT side with our agreements that we have with Cisco as a subcontractor, as well as with Rockwell Automation's network and security services and our system integrator partners. So we're able to help span this whole connected enterprise area and bring some of the best practices and training to help simplify. There are also design tools that Panduit provides that can help you with layout, part selection, calculators, templates. These span from being part of Rockwell Automation's proposal works, where you can select all the parts we looked at today, fiber optics, copper, zone enclosures, that even include configurators inside the tool where you can select which model switch and what size housing and specify the zone enclosure or what type of fiber. So Proposal Works is a free tool that can really save a lot of specification time. Integrated Architecture Builder, also from Rockwell Automation, allows you to look at the architecture itself and how you link switches together. And then these other design tools that are available from our website with AutoCAD files and so on. And finally, some resources. We talked about converged plant-wide Ethernet, but Panduit has developed our own 400-page guide on the physical infrastructure that's available on our website, as well as white papers on microdata center, control panel, scaling networks, how to use the design tools, etc. So I encourage you to visit Panduit's site and find these technology briefs and tools, as well as to visit Industrial IP Advantage. You see the URL there. We're excited to announce we now have network design e-learning course available through our site that has 20-minute modules on cell area zone deployment today, and it will grow to go through industrial zone to the enterprise for a total of 16 hours or so of training by early 2016. So I encourage you to visit Industrial IP Advantage for all the articles and to sign up for our training. So in summary, the connected enterprise and Internet of Things requires a strong physical network infrastructure, but there are real ways to simplify that by leveraging reference architecture, maturity models, building blocks, and design tools that can improve your performance and uptime, ease the integration, and reduce your cost and time to achieve the value that's at stake with Internet of Things and connected enterprise. So thank you.
Thanks, Dan, for the presentation. We'll get to a few audience questions now. The audience listening live can type in questions for today's presenter in the Ask a Question box on the screen. I already see a few submitted. We'll get to as many questions as we can. Within a few days, this presentation will be available for on-demand viewing. We'll post the archive on the Control Engineering website and then send out an email message with a link connecting directly to it and to related resources after it's ready. Now, on to the questions. So the first question, what are some of the key areas to include in corporate plant-wide physical infrastructure standards for industrial plants?
Well, we definitely touched on many of them today. The media, the connectivity selected for the industrial environment. But some of the areas that don't get enough attention include the grounding and bonding for the telecommunications equipment across the plant floor, the pathways, the enclosures and cabinets. So Panduit has boilerplate and also training and guidance to help you develop more comprehensive physical standards.
Good. What are some of the annual planning recommendations for physical infrastructure that somebody should do on a regular basis?
Well, By conducting audits, looking at the enclosures, the state of your documentation and moves, adds, and changes can be an important part in developing a plan. If it looks like some of your areas of your plant have had some updates, getting some new infrastructure, it may be time to look at how do you scale that. You may need to update and add new switches or look at how your backbone is deployed to that area of the plant. So at this annual planning time, it's a good time to maybe test some critical links if you have a plant shutdown, but it's an area that often is neglected.
What are some of the key reasons to deploy industrial Ethernet switches in a separate zone enclosure rather than in a control panel?
The natural inclination is to put the switch with the equipment in the panel, but when you start looking at things like power bumps and resiliency and installing fiber optics, it may make more sense to house the switches, industrial switches, in a separate zone enclosure where you can bring in that fiber backbone, test it, and secure that cabinet with some high availability power so that your plant backbone and those key access switches have a more controlled environment that's also more accessible to network professionals, whether they're manufacturing IT or operations side.
Right, that modular design is good for security as well.
Yes, that is one of the keys, being able to lock an enclosure and limit it to qualified, trained individuals that know the network versus sometimes the switches are shoved into enclosures that may not have qualified people entering them. They may be electrically qualified, but what do they know about networks?
In which cases or industries are fiber optic cabled backbone properly justified? Isn't that too much bandwidth for a standard plant or enterprise communication for the money?
Okay, great question. The fiber optic, one of its benefits is bandwidth. Some of the fiber types have a very high bandwidth capability, and that's recognized. But when you start looking at other reasons to use fiber in a process plant between buildings where there's lightning hazards and so on, the noise immunity and being an optical method is preferred or required. Also, you need to look at, if you're looking for high availability and forming a ring switch, or you're using redundant uplinks from a switch, using fiber actually gives you a performance benefit over copper. The switches recognize the loss of light of a broken link and respond and heal over the network faster than it can detect with copper. Copper relies on the protocol, whereas fiber, it's the loss of light. So it can be an order of magnitude faster, maybe the difference between shutting down a production line or keeping it running.
And I think you mentioned training as well. A lot of people are using videos right on the plant floor in the facility site as training, and you need that kind of bandwidth for that and for the mobility devices. Good.
Thank you. Yeah, that's the other aspect of looking ahead in your planning is to consider your bandwidth needs now and then in the future. With video coming, more wireless, many of the controllers and subsystems are going to be more gigabit based in the future, although the packet size and your network loading can be low when you start aggregating all these different data traffic types. It can be money well spent.
Who should lead the convergence between IT and OT?
Well, that all varies on the industry and the personnel and staff on staff. So when we look at the machine and process level, often the IT staff doesn't want to contend with being responsible for uptime or the machine control operation. But the plant-wide network, when you start talking about letting in remote experts or doing wireless throughout the plant, it really needs that kind of partnership. And ultimately, I think both IT and operations control engineers need education and a common vocabulary and holistic planning together to really move ahead.
Great. What are the recommended training paths for e-learning or instructor-led training for industrial networking?
As I mentioned in the slides, Industrial IP Advantage is pleased to announce we're launching a broad-based network design class that we feel will be a good first step, whether you're a system integrator, machine builder, or an end customer, to all have that common vocabulary about VLANs and IP addressing and security. And then ultimately, the IMINS courses from Rockwell Automation and the Cisco certifications are creating a new career path potential where the know-how to configure and troubleshoot the command lines through command line interface to routers and switches can become part of a manufacturing IT practice so that automation can be take full advantage of the power of the networks.
Sure. Maybe you could talk a little bit about the scope and the benefits for installation services for physical infrastructure.
Sure. So we talked about that maturity model and reference architectures and some of those best practice standards from organizations like TIA 1005 or the European norms standards. The areas that infrastructure and services can help you with our assessments, where we can grade and look at the enclosures, the grounding and bonding, the pathways, the media selection, the status of your documentation and identification. So that can have a big impact on troubleshooting and support. The status of security, from the physical level, are enclosures locked, or open ports blocked off, or critical connections secured. And then partnering to look at the logical network and the bandwidth and how you're using managed switches. These are all areas that Panduit installation service with our partners and integrator partners can help with.
Thanks, Dan, for answering the questions, and thanks everybody for submitting the great questions. Dan McGrath, Solutions Manager, Industrial Automation Infrastructure Group, Panduit Corporation, joined us and shared his expertise today. We sure appreciate him spending time and taking the extra time to answer the questions. We'll get to more offline after the webcast and hook that into the connected resources area. I'd also like to thank Panduit for sponsoring the webcast. Now that you're just about done, we want to hear how we did. The exit survey will pop up when your screen, when the webcast ends. Take a moment to complete it, as we use this information to improve future webcasts. On behalf of CFE Media and Control Engineering, thanks for attending this webcast. Copyright 2015 CFE Media. This concludes our webcast for today. Thank you.